Next, let us talk about structure and unions in C++. Before this section, we already went through in this chapter about array. Array is one example where we can combine a few values of variable to become one name. And that one name is referring to the same type of data or variable. What if we have a few variables that may not be the same type, but we want to refer it somehow as one entity? In C++ and many other languages that follow its style, we can actually group a few variables logically. So beside arrays that group similar data as one variable, C++ provides a way to consolidate a few variables, perhaps of different data type, but they are related. By doing this, the consolidation of these variables will make working with them more systematic. This is actually related to many engineering entities that involve in the calculation, like vector that comprises of a few unit vectors. So we combine the unit vectors together to become one entity that we call vector. Another example is complex number. The component is imaginary and real part, coordinate, and many more. In C++, this consolidation of data is called structure, and it is constructed using struct keyword. Then there will be a question about what is the syntax to declare them. So this is the syntax, the keyword struct followed by structure name. In this case, the structure name will follow the same rule as the variable name, and then it is followed by a pair of curly bracket where in between the curly bracket we put the variable that we want to combine together preceded by the data type. So this is the syntax. The variable that we declare inside the structure is what we call member of the structure. Structure is actually just a data type. Regular data type like float, double, and integer, we can initialize when we declare it. Array also the same case. So structure will have some kind of syntax to allow initialization during declaration. Structure can be initialized the same way array is initialized by listing the values in curly bracket. The values will be assigned according to the ordering of the structure definition. For example, if we declare a structure named matrix, struct matrix, in between the two curly bracket that follows, we declare for double A, B, C, D to constitute 4 elements in 2 by 2 matrix. If this is the way we declare the structure matrix, then if we want to initialize a matrix structure, when we declare it, for example, we have a variable named mat. The type is structure matrix. We want to straightaway give value to the member of A, B, C, D. We put the value in between curly bracket like this. So each of the values will be assigned to each of the members in sequence. In this case, the matrix mat in this C code is actually equivalent to the mathematical representation like this. It's A, which is 7, B is -10, C is 0, D is 1. So in this C line, and then in this C initialization and declaration, this is what we want to represent in the abstract mathematical world. In the next slide, we will see that this means the member A of a mat is given value of 7, B -10, C 0, and D is 1. We need to use the dot operator. Other examples of structures that we can create using C, C++ struct construction. One example is vector 2D, struct vector 2D. Perhaps you want to check why we cannot declare this 2D vector. What error will we get if we declare this vector as 2D vector, 2D at the beginning? And this is how we declare it: double ij, the component of the vector, vector 3D, double ijk, complex, real and imaginary, ri, coordinate 3D, double xyz, and color, also part of engineering work. We can give the component of RGB. This is just very few examples of structure that we can make for our use in engineering calculation. Now that we know how to declare and initialize values to structures, we need to know how to access them. In this case, accessing structures means we want to read or write values into the members. Accessing members of structures is done by using a dot operator. For example, let's say we have the structure just now, a mat. To access the value from the member C, we put a mat dot C. And by doing this, we actually reading from C. And if you want to transfer to a member of another structure matrix, for example, another structure matrix called trans, we want to give from C to B, we put dot B at trans. We can give a constant to the member of a structure. For example, we can give 10 to real member of a variable which is a complex number structure, com.real. So we use dot operator. But if it is a pointer to structure, pointer is the topic that we learn in the final chapter. If the structure is a pointer, to access the member, of the pointed structure, we use arrow operator instead of dot operator. We will not cover so much of structure pointer, but it will be used in your GUI because in C++ GUI, the handle that is used by Microsoft as a managed pointer is actually pointer to structure. So for GUI project, you need to use arrow operator. One complete example of the use of a structure. Now the structure is for a complex number, struct complex. We have two members, R and I. Both are double. Then we declare two variables, A and B, of this structure. Then we initialize with values like this. Then we want another variable C to be structure complex also, but the value is A plus B. And from maths, we know that the real part of the added complex number is the addition of the real from the both operand, the same to the imaginary part. One way we can do this in coding using C++ is that we don't have to initialize, but instead we call the member R from C, and then we assign it with the addition of R component of A and R component of B. We do A.R plus B.R. That is for real part. We do the same for imaginary part. C.I we assign with the value of A.I plus B.I. This calculation is not really programming, but it is mathematics. It is defined in maths. Next is union. Besides structures that provide logical grouping of related variables, C++ also have another data structure called union, which provide a logical blending of variables. In a moment, we will see what is the meaning of blending of variables here. All syntactical and usage aspect of union is identical to structure. For example, is this one. This is declaration, members, and type of members. And this is the union name. How do you read and write to the members is the same as the way we did for structure. The key difference between structure and union is that structure simply groups variables together. This means the variables don't interfere each other. However, unions blend the variable member in the sense that those variables reside at the same memory location, which means writing into a member will override into the other members as well because they are in the same place. Size of a structure is the total of the size of members because we simply combine the members. But the size of a union is the size of the largest member because the members of the union reside at the same place. What will appear as the size of the union will be the largest member. That is how it's blended. However, since union is very similar to structure but has very little application at high-level programming, either in engineering or computer science field, we won't go so much into detail of this topic. So knowing about union is just for your information and so that you have some subconscious knowledge about this. If someone talk about union in C++.